So here we have a integral. It looks like a daunting integral involving sine and cosine. And you could try to you always try like a u substitution first, and you can just try to let u be sine or cosine, and you can see it won't work. So what we're going to do for this integral is make use of this Pythagorean identity and the fact that we know these derivatives. So since the derivative of sine is cosine, when you use u substitution, if you just had a cosine factor remaining, the du works out perfectly, or vice versa. If you just had only cosines and one sine remaining, then if you let u be cosine, then the du would take care of the sine. So hopefully that makes sense. Doesn't sound like it made sense as I was explaining it. So let's go to the problem and see what we can do. So this Pythagorean identity can be used to change cosines into sines, or vice versa, whatever you need. So if you look at this problem carefully, if I took this sine and thought of it as, instead of sine cubed, sine squared, times sine, and I won't write that sine just yet. Oops. Like this. This is an equivalent integral, obviously, but here's why this is useful. This Pythagorean identity allows me to change any sine squared into only cosines. So if I use that, and then this whole part of the integral would be only cosines, I can use a u substitution, because if I let u be the cosine factor, then du is going to include the sine factor, and it's going to work. So we're going to try that just to see how it works. So here we go. I know that sine squared is, according to my Pythagorean identity, 1 minus cosine squared. That's being multiplied by cosine to the fourth, and I can distribute that. And the sine 2/3 x dx, we're going to save, because that's going to be our du factor when we use the u substitution. So let's just let that hang out for a little bit. Now it's going to be easy to integrate if I can change this to a difference. So I'm going to distribute my cosine to the fourth to get this. Cosine to the fourth, 2/3 x, minus cosine to the sixth, 2/3 x, and then times this du factor that I've been saving. And now I can go through my u substitutions. So if I let u be the cosine factor, so I'm going to let u be just the cosine of 2/3 x. That would make my du equal to negative sine 2/3 x times 3/2. I'm sorry, times 2/3, the derivative of the inside. So you can see the whole reasoning behind this. I have that du factor. Now it's a pretty straightforward u substitution. So my cosines are now all u's. My sine 2/3 x dx is exactly equal to du times this reciprocal, because I'd multiply it over here, negative 3/2. And now this is a very, very simple integral, which is the whole point. So this is negative 3/2 times 1/5 u to the 5th minus 1/7 u to the 7th. And then remember, since u is cosine of 2/3 x, I have negative 2/3, or 3/2, sorry, times 1/5 cosine to the 5th of 2/3 x minus 1/7 cosine to the 7th, 2/3 x, plus c. And now if you want, you can obviously factor out cosine to the 5th. You can factor out maybe a 1/35th if you wanted to get rid of these fractions. You could do all that up at this step as well. But I'm going to leave it unsimplified. And that's the unsimplified integral. So that just gives you an idea how this works. It's not too difficult. So practice it.